Welcome to Geometry for AP. Tonight we're going to talk about perpendicular and angled bisectors. We've talked about angled bisectors before, but never in the context of a triangle. We're going to do more about that now and learn the properties of these two special segments. Okay, if you would please write down your essential questions for your video tonight and always title your notes. All right, and so pause the video and get those down. All right, so we got a little vocabulary to hit tonight. First of all, let's go through angle bisector. If I have a triangle on an angle bisector, it kind of looks like this. And so we have a triangle, and there's one angle bisector. There could be three angle bisectors at most. And so it bisects the angle. So we ask these simple questions. Does an angle bisector go through the vertex? Yes, it does. It goes through that point right there. And does it go through a midpoint? And some of you may be thinking yes, because you keep doing your proofs like that, but it does not. Angle bisectors do not have midpoints. And it also does not make a right angle. Okay, so those are the properties of it. And so the setup would be angle. Let me get my pen back on here. Angle equals angle. Okay, and that's our setup. So know the properties of an angle bisector. We'll talk about some of these other things in this chart later on. All right, so then there's perpendicular bisector. We've hinted at this one a few times. We've never really used it, so now we're going to use it. So perpendicular bisector looks like this. It's both a bisector and it's perpendicular. So does it go through a vertex? No, it does not. Does it go through a midpoint? Yes, it does, because it's a bisector. And does it make a right angle? Yes, because it says it's perpendicular. So the setup for this one is the angle is equal to 90 degrees, and the part is equal to the part, just like our bisector setup back in the very beginning of the year. All right, and so these are our two figures and these are our setups. Now I'm going to add in some other properties tonight, some other theorems that give these segments special properties, so make sure you pay close attention to those because they'll change some of the setups of things. All right, so here's our first example. So pause the video, write this information down, and then work this problem, and then turn the video on when you're ready to see the answers. Okay, so now that you're working this problem, it says a perpendicular bisector, so that means we've got a right angle. And it's a bisector, so since it's a bisector, that means we have two congruent segments here because there's a midpoint. And so BDC goes right here, and we know that's a 90-degree angle, so 2x squared minus 38 equals 90. That's the square root method. When you're done solving this, you should get x is equal to a positive and negative 8. For the two segments here, we got DC, which is equal to this one, ED, which is equal to this one. This problem asked for EC, so the problem wants this whole thing at the end. And so what we get here is we get 7y minus 5 equals 5y plus 7. When we solve this, we get y is equal to 6. And so when we finish solving this problem, we get that EC is equal to 74. I think that's right. Yeah, 74. All right. And so there's your answers, and we can put units here after this. So make sure you have all your work that goes with solving those equations. All right, so now we have our first couple theorems. So highlight these theorems. The first theorem says perpendicular bisector theorem, which says that if TM is perpendicular to AB and MA is equal to MB, then PA is equal to PB, which that says is that any point located on this perpendicular bisector will always be equidistant from the endpoints A and B if it's on the perpendicular bisector. Now the converse says that if you have a point that is equidistant from the endpoints of a segment, then that point, point P, has to be located on the perpendicular bisector. So if you go back and look at these proofs here, are these two triangles congruent over here in this one? Is this triangle and this triangle congruent? And you can say, yes, they're congruent by HL. Or even if you're not even looking at this information, this is reflexive property. So yes, these triangles are congruent. That makes this piece and this piece congruent by CPCTC. If I go down here and I put a line through P that's perpendicular, there's a perpendicular postulate for that. And that means I can do reflexive property here. that means that these two triangles are congruent by HL, which means that any other parts are congruent, which means this part right here and this part right here is also congruent. So we have another reason. So make sure you know these theorems. We're going to use those in solving some information. Okay? All right. So here it says, find the value of x, find TW, find WZ, and this. So pause this little problem right here, and then we will go over it when we're done. Okay? So pause this problem and work it, please. All right, so the first thing we want to see here is it says, we look at the figure, and this is a perpendicular bisector. So if it's a perpendicular bisector, that means 3x minus 5 is equal to 2x. Because any segment that's located on the perpendicular bisector is equidistant from the ends. So we get x is equal to 5. I wrote that backwards. Let me rewrite that there. X is equal to 5. So it says find TW, so TW will be 10. So let's find WZ, which better be 10 also. It's 15 minus 5, so that's 10. It says if R is on the perpendicular bisector of TZ, then R is blank from T and Z. And or what here? So R is equidistant and from T to Z, and we know TW is equal to ZW. I get my letters right here. ZW. All right, and so there we have it. Make sure you have all that working in your notes, please. So I'm going to let you pause this one, work through this problem, and then we'll have this one to check when you come into class the next day. I'm not going to give you the answer to this one, but if you don't get the answers or you're not sure about your answers, make sure you ask in class. All right. Here are the two theorems that have to do with angle bisectors. The angle bisector theorem here says that if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. So if QS bisects angle PQR, and this SP and QP, no, SP is perpendicular to QP, and SR is perpendicular. So as long as these segments are perpendicular, then we know that these two segments here have to be congruent. And here's what you need to look at. Look at these two triangles here and here. Now, looking at this information, couldn't I put reflexive property in here? And so these two triangles will be congruent by angle, angle, side, and angle, angle, side. So if they're congruent by angle, angle, side, so are all their other corresponding parts, which means PS would have to be congruent to SR. And that's why this is a theorem. This stuff can be proven later on by CP/CTC. Just like right here, this one says if SP is perpendicular to QP and SR is perpendicular to QR, so if we got these perpendicular segments, I could put a segment through Q and S. Couldn't I do a reflexive property? And then by HL, these two triangles are congruent, which means these two angles have to be congruent by CP/CTC, and it's the converse of this setup. Okay? So again, all these theorems are starting to come in effect, have congruent triangles in their theorems, and that's how they prove these theorems. So highlight those in your postulate theorem sheet. All right, so when you're using angle bisector, here we have two segments marked, 7x and 2x plus 5. So first, what do we know? Whoops, I didn't mean to write that mark there. We know that NR bisects angle LMQ, so we know they've got a bisector here. We know that RM is perpendicular to NL, and we know that RP is perpendicular to N. So we know we got these perpendicular marks. We go to a bisector. Well, what do we need to know? We need to know the length of RM, because that's what this question asks. So if these segments are perpendicular to the sides of the angle and we have an angle bisector, then we know that we can write an equation for solving for that. And we know that RM is going to be equal to RP. And so then when we solve this, that would be 2x equals, or 7x equals 2x plus 5. We solve that, we get 5x equals 25. X is equal to 5. But again, we wanted to know RM, so we go back and plug it back in. So RM is equal to 7x. So 7x times 5 is 35. So we know the length of RM is 35. And RP would also be 35. And that's how we use the angle bisector theorem. Now, if we look at these three, it says find the value of x. So find the value of x for each of these and have those in your notes so that we can check to make sure you did those problems when you get in the class. Okay, so you should have those problems done. All right, so here's some more practice. Pause the video, write this problem down, do all the practice of the problem. When you come to class, we'll be able to discuss these. Okay, you should have those done. All right, so now we get to this last problem. And I'm going to work through this whole entire problem. You may pause the video if you like, but I'm not sure if any of you will be real good at working this problem. So there will be one like this on the test. So make sure you work. You have 4 of these in your homework. And so this is one of the 4, so you better have this one done. You're not going to get credit for this one, though. You got to do the other 3. So if you look at this is a perpendicular bisector. And if it is, then that means this piece has to be congruent to this piece. And so this piece here is congruent to this piece. So I have 2x plus 3 equals 2y plus 1. And I've got 5x minus 1 equals 3y. So I got 2 equations with 2 variables. That's a system of equations, so I need to get it in standard form. So this is going to be 2x minus 2y equals negative 2. And I got that because I subtracted 3 from here. And I moved the 2y over. This one here, I need the same thing. I got 5x minus 3y equals negative 1. I got to the negative 1 because I moved this one over by subtracting 1 from each side. Actually, I'm adding 1, so really that'll be a positive 1. All right, so 5x minus 3y, and so when we line these up, and 5x minus 3y equals 1, I want to get one of the variables to cancel. I'm going to go with the x's. They're in the front. That's just what I'm going to pick. So I'm going to take these 2 equations. I want them to both have 10, but I want one to be a positive 10, one to be a negative 10. So I'm going to do a 5 here, and I'm going to do a negative 2 here. And when I do that, I get 10x. Oops, sorry, it's moving all over the place. 10x minus 10y equals negative 10. When I do it to the other one, I get negative 10x plus 6y equals a negative 2. Whole point of elimination is to eliminate one of the variables. The 10s cancel. The one's positive, one's negative. So I get negative 4y equals negative 12. And so y is equal to 3. Now I want to get an x value. So I'm going to go back to one of my original equations. I'm going to use this one right here. So 5x minus 1 equals 3y. So 5x minus 1 equals 3 times 3. So 5x minus 1 equals 9 plus 1 plus 1. 5x equals 10. X is equal to 2. Now, this has an x and a y. So since it has an x and a y, it's a system of equations. I should write my answer as an ordered pair, 2, 3. And this is my work. So let me remind you here that when you do this, that you want these 2 to be opposite signs, but the same number. And so whatever you have to do to get that to happen, which I multiply by 2 different numbers here, you do, but make sure you do it to the whole entire problem so that the variable eliminates and you have one variable left, then you plug back in. That's a system of equations. It's always best to have it in standard form, ax plus by equals c, before you start working it. And that's the end of our notes for tonight.